So today I have the distinct pleasure of welcoming Dr. Micky Marinelli to join us. So she comes as an outstanding researcher and educator from the University of Texas at Austin, where she studies addiction science. But I'm particularly thrilled to talk to her today because she's the recent recipient of the NINDS Rigor Champions Prize. And that prize, if you're not familiar, is an award that's given to individuals or small groups who go really above and beyond in promoting research rigor and transparency. And so Dr. Marinelli received this award for a course that she developed titled Analytical Skepticism. So in this session, she's going to begin by showing a little bit about her course structure and sharing about that course. And then her and I are going to join you to have a discussion about teaching scientific approaches to teaching scientific rigor, the culture of rigor, and what this prize really means in itself. Okay, thank you.
The whole argument.
I'm going to stand over here.
There we go.
Great. Thank you so much for this. So yes, this is who I am. I think this cursor works. There we go. And ooh, okay. And let me go back. So I teach this course. And this course is really given to people who are already in science or who want to become scientists, but I've also adapted it to the lay public with the ultimate goal of doing and consuming better science. Okay, so that's the ultimate goal. And I'm going to tell you a little bit about the structure of the course. So it is structured with 7 modules. They're quite self-explanatory. So the first one is about seeing, visualizing, but also seeing outside data, not just what you produce, but what you interpret, and communicating data, cognitive bias and scientific bias, then approaches to testing hypothesis, basically experimental design 101, assessing probabilities or how difficult it is to assess probabilities, and therefore we do need statistics, so the next module is about quantifying and analyzing data. And then the last one is the most complex one about normalizing data. What do you do when you want to combine different experiments or present ratios about different things? And I think what I do is kind of novel because in addition to the topics over here, in all of them, I cover common conceptual mistakes that people can make and also careless mistakes. And then another thing that we as scientists think we are immune to, but we've seen throughout this conference is really irrational behavior or unconscious things, ways in which we judge information. And I use all of these throughout the entire course. In addition to what I teach, which I think is quite intense, I also teach it in a way that is kind of perhaps novel, or at least it has a lot of information. So in addition to regular lectures, that's me with my blue hair, and lots of homework that people do ahead of time before they come to class. We have lots of live exchanges, but lots of live e-surveys as well, with the goal of having students have these sort of aha moments that they can sort of realize, oh my goodness, I am biased in the way I'm thinking, or I didn't think this straight, and hopefully then they can do better science. We also have loads of in-class exercises that they can then correct and then return. So it's sort of formative type of assessments. Lots of hands-on activities where I try to use the 5 senses, smell, touch, taste. And then also they do 3 projects. And then finally, they do a lot of practice. And so a lot of times we try to spray information and pray it sticks. So this spray and pray approach I don't think really works for these complex things. So by giving them lots of practice, I hope that they can really do better. And because it's so much, it's really a 60-hour course per semester. But I have adapted it to smaller bits and portions for different audiences, with the ultimate goal is that all of these things that come in the way of science can be reduced so that we can actually do better science. Okay? So I'm going to show you a few examples of how I do this. The first one is about communicating data. This is about exercises, and I tried to choose examples that you haven't covered already except for one of them. So the first one is I give them a table like this with different subjects, and ooh, my goodness. They have hormone levels in the morning, AM, and afternoon, and I ask them, plot these data, what's going on? And they plot it, and they come up with something like this. So this is the entire population, and you can see that there's a nice fluctuation in hormone levels between morning and afternoon. And then we go over the importance of showing individual data points, not just averages, aggregates. And when they do that, they see a very different pattern. You see there are two subpopulations in this. These are the exact same data, but plotted as individuals, and one has big fluctuations, and the other one doesn't. They wouldn't see this if they plotted the entire averages. So this is the type of practice that they do to spot things out. Then I tell them, okay, so this is what the data, the table looks like. We color-coded them like this one above. Now organize them, so I have the top part is the subpopulation 1, the bottom part subpopulation 2, and they do it, and you see they did it quite well here, but here they forgot to organize this column over here. So now we have a careless error in addition. So they practice doing stuff that really spots how there can be conceptual and careless errors as we approach science. Another example is with cognitive biases. These are really my favorite ones. We cover so many of them. A lot of them you cover as well in your C4R modules. And I take from different scientists. Kahneman is my favorite one, Gilovich as well. And this is an example of irrational behavior or unconscious judgment. I gave this to residents in psychiatry. I gave them a description, you don't have to read it, about a child who's in school, has difficult behavior. And I color-coded them here just for you, not for them. Behaviors that have to do with inflexibility or feeling overwhelmed or refusal or defiance, okay? And then I asked the class, tell me what describes this student in this class. And half the class will tell me stuff that has to do mostly with oppositional defiance, although some of them also tell me about overwhelmed. And the other half looks quite the opposite, is mostly inflexible and overwhelmed. But they're given the same exact information. So why is half the class telling me one thing, the other half the other? It's simply because I told half the class that this was a description of a child with oppositional defiant disorder, and the other class I told them it was for a child with autism spectrum disorder. So they have this expectation of finding things that have to do with oppositional behavior or autism, and so we discuss about how expectation can really bias what you're able to see. So basically you see what you're looking for and you don't see what you're not looking for. And we discuss how it's important this in our daily experiments where we have to judge constantly, but we are unable to judge if we have a priori information or beliefs. The scientific bias is something that you've covered a lot. I take a lot, I don't know if you've read this book, Bad Science by Ben Goldacre. I really highly recommend it. And I'm going to give you an example of something that covers these two things with a hands-on activity. So I give them a population and I tell them, divide this into 3 experimental groups of 12 subjects each. And so they stratify the population, and while some students will take 2 of each, the proper one is to have a representative sample of the population, so fewer subjects that look like this and more subjects that look like this, so they have to create the experimental groups. And this is a hands-on activity, and then they can eat the nuts as well. And this is the type of stuff that we do. The final one is just to show you what the actual exercises look like in approaches of testing hypothesis. I talk about the importance of dose-response curves in biology. They are often inverted U-shaped curve like this one. So where we have sort of like the Yerkes-Dodson curve, we have little effects, little response at low doses, then it peaks and then goes back down. And let's imagine this is a group of solid, let's call it solid, but another group has a different curve that's shifted to the right with less potency. And I tell them, tell me what would it look like if I, instead of doing the entire dose response curve, I only looked at one dose, 20 milligrams, and then 40, and then 80. And this is an example of their answer. So they plot it at 20 milligrams, the hash looks lower, at 80 it looks higher, at 40 it looks the same, and that's how they say, this is their own comments in their assignment, single dose tells us nothing. And so this is another thing about doing good science that we have to think about, is that we often do single dose studies, but we could get very opposite results according to the type of dose that we get. And then I do the inverse. What if I had something like this? What could it mean? And they show me in an inverted U-shaped curve what it could mean. And in this case, they only did one example, so I tell them revise the work, and they revise it, and they show me the other curve. So basically, that's sort of overall, oopsie daisy, it went away. Oh, okay. Overall, the kind of course that I do, all these different modules with all these different possible errors that can happen with the ultimate goal of decreasing them and doing better science. And at the end, students, it's really hard course, but they appreciate it a lot. These are some examples that, of comments that they tell me the class ruined me, I can't look at anything without finding fault, change the way I see the world, better critical thinker, be better scientist in the future. So the goal is that now having all this information, at least knowing what can go wrong, they can do things right and, spread the word and keep going. So that's sort of the overview of my course. Thanks.
So thank you, Dr. Marinelli, for sharing that with us. You have some outstanding examples of how to engage students in these ways, and I think we can learn a great deal from you. You're amongst friends here, right, where we value rigor and want rigor education to happen. And part of the work of C4R is to give and develop lessons, develop curricula that others can use to educate, because what you've created is no small feat. So I want to start off by asking you, like we recognize that here. I want to start by asking you, what was your motivation for creating this as a course, building this from the ground up?
Yeah, I think I used to teach a very basic statistics course at my former institution, and students kept giving me their data to check, hey, did I analyze it well? And every time they gave it to me, I saw errors in not necessarily the findings, but how they structured their experiments, that they didn't have a proper control group, or they had it, but it wasn't run concurrently. It was run by a different person on a different day. And so when I saw this, I said, this can't be. And I was actually recently, I should have known this all along, but I was diagnosed with obsessive compulsive personality disorder. It's not the same thing as obsessive compulsive disorder, it's a different thing. And it's something that you really have a belief that certain things are a certain way, and when they're not, you feel really, really bad about it, and you want to make it right. And that's sort of my motivation was, no, we can't. And I'm such a person who loves the truth that I saw that all of these things kept in the way of finding the truth. So I decided to build that, and I built it basically based on a lot of errors that I saw that students made. Yeah.
That's really interesting. When I think about your course, so as an educator myself, and I actually truly love developing courses and curricula and programs, one of the things that I see continuously is this challenge when we talk about rigor in assessing rigor, right? Because there's so much variability in what rigor looks like, depending on subdisciplines, et cetera. And so one of the things I was thinking about when thinking about your course is, how do learners demonstrate growth throughout your course?
Yes. So many different ways. So you saw those assignments where I said revise, and then they revise it. So as they begin the course, there are lots of revisions, back and forth, maybe 5-6 times each student. At the end of the course, they got it. And you can see that there are many fewer revisions. So the frequency of having to revise the work. The other one is they do projects. They do 3 or 2 projects, depending on the year, where they actually implement an experiment of their choice, testing a cognitive bias of the choice. Might it be the anchoring effect, or opt-in, opt-out, one of these things. And then they do the experiment, they analyze it, and they show it. And seeing how wonderfully they do it, I think that really demonstrates their growth. Yeah.
I think that's a really important perspective and insight, because again, one of the challenges is either acutely or longitudinally, how do we begin to measure if rigor is getting better? That's a consistent challenge. How do we evaluate this? And when I think about, I can tell that you have incredible passion for this course, and I understand I have passion for this course now after hearing that, and I'm assured that your students adore it. Do you yourself have a favorite element of this course?
Gosh, I think the cognitive bias is the best one for me. I love it. It's just, I think it's only 4 hours long, but we go through all the Kahneman you know, things that he found and how we see patterns where there's only randomness, and I prove it to them that they see that sequences that are random that they actually think are not, or opt-in, opt-out is a fantastic one, where according to how you pose the question, you might have different, totally diametrically opposite results. So that's my favorite one.
I can only imagine, like, in that course setting, you can probably see your learners, their faces light up. Like, you can see the aha moment.
You can hear it
which is
sometimes,
so precious,
right?
yes.
Wow, it's really nice, yes.
I like that. The other thing that I was thinking about in the context of looking at, like, traditional university-style education, where rigor and rigor principles are taught in a variety of formats, or maybe not taught in a variety of formats, what was the perception? Did you get recognition initially, or what was the perception of this course by maybe your department or university level? You know, was there an impression of it? How did that work?
To be honest, it wasn't, I mean, it started getting a little bit of notoriety because the students put me up for awards, and I won some awards for it, but a couple.
Does that have to do with the
many.
Texas 10 award?
Yes, the Texas 10.
Yes, so she has a Texas 10 award, which from my understanding, correct me if I'm wrong, is put up for the students for, it's an acknowledgement that a course and an instructor has made a significant impact
on their lives.
Yes.
And it's the 10 best of the entire university. So that was
cool.
a really good one, and it's nominated by the students. So that was one of them. And so, you know, I feel acknowledged by the students, but then, you know, the department and the college, they didn't really know what I was doing, because this is, again, it's a student award, so they might not even know necessarily about it. But I must be honest, one thing that really changed is getting the Rigor Champions Prize. Once I got that, it was like an acknowledgement of something, and so people started looking at my course with different eyes and appreciating it, like it gave it validation, I would say. So I was very thankful for that, yeah.
And that kind of leads me to this, the second part of this discussion, which is when the, you know, the notification or the information about the Rigor Champions Prize came across your email, your desk, whatever. What motivated you to apply for it?
Yes, so actually I didn't, even though I was part of the Rigor Champions you know, Slack, I hadn't noticed it. And so someone came to me and said, look, this looks exactly like the course that you're making, someone who's in my vicinity. And so I looked at it and I said, you know what, this is exactly what I do, and I'd like to be, I know it sounds maybe arrogant, but recognized for what I do. And I applied, and I got it, and I was very, very happy. And I don't know how many people applied. Maybe there were only 5, and I was one of 5. But I'd like to imagine that the course had something to do with it.
And again, I'm not obviously in charge of the award, but I think that I'm recognizing as an educator and amongst this group, the amount of dedication, like under, you know, this going above and beyond, the dedication and amount of work to build something like this individually is outstanding. Like you deserve recognition for that.
The cost, you know, buying nuts, and I do things with berries, and I do things with chocolate coins to do probabilities where we toss them and see that HTT is more common than HTH, you know, and that's that type of thing.
I will say I had one course that involved food, and I will never forget that course. So if not, that's a more impactful element than you may even know. And I think about it when we think about your award and the Rigor Champions Prize. You've kind of alluded to this, but how do you think that prizes like this or recognition like this can influence the culture of rigorous practice? Do you think they're motivational? Do you think, and I know the office is here, but I want to hear from someone who's been awarded, what do you think the impact of these prizes can be?
I think it is definitely motivational. It makes me feel that I'm not alone doing my little thing that no one knows about. It becomes real. And then I think it's looked upon differently by the institution. Like, oh, you know what, maybe it's something that's valuable. I mean, I thought it was valuable, but now you have a passport that shows it, you know?
Right.
And so I think that after I got that, they contacted me from the whole college saying, do you think we can expand this to the entire undergraduate population? So it started building a culture of, you know what, maybe this is interesting, and it's recognized by the outside. I don't know how to explain it, but I think if you are given a recognition that's reputable, it totally changes the value of something. Yeah.
And thinking back to what your learners experience, they're going to be learning through your course structure multiple elements, multiple principles and practices that relate to, of course, scientific rigor. If you had to take away, like, if you wanted them to take away one thing or one practice or one skill, that's a hard question, I know.
I know.
Like, what would you want them to leave with?
It's every module, you know, in fact, every class. If there's one thing you have to take from this course is, and I keep saying them, so I have so many, don't use pie charts, you know, don't don't violate the error principles, you know, never do multiple t-tests, you know, all these things. I always find myself telling them, if there's one thing, you know, be careful about Simpson's paradox. I don't know if you know about that. That's a really common mistake if you have data like that, where it tells people, it gives really the wrong information and people get the wrong results if the proportions are different according to subpopulations. And so I do all this. So I don't know. I think the bottom line is be a critical thinker and always be humble, thinking that maybe there is something that I haven't noticed and I can learn. And so, you know, to do better science. Another thing that I think is useful is collaborating. So once they work in teams, they really see that someone might not have seen something, but someone else has. So working in a silo might not be useful, but working with someone with a very different mindset. So, you know, be critical, work together, never do multiple t-tests.
I see, like, even that first student comment you presented, this sense of skepticism, but in a welcoming, you know, non-sour way, you know, like
hopefully, you don't know what it is to go to a place and see mistakes everywhere. It's really damning, but
I think that's something that you know, amongst educators here, that is a theme, right? How do we get them to recognize and become aware of the principles and practices and rigor, but in a way that isn't depressing?
Yes, right.
You know, stuck in that space.
I think doing projects at the end and seeing how successful they are gives them the, you know, motivation and the oomph. Yeah. I
think that is probably incredibly special for them. So I was thinking about this, being that you have this course, being that you've developed this curricula, and it's by and large successful, right? I mean, students are learning, they're enjoying it. I wonder how, and I think this is very relevant to the group here, I wonder how you envision the future for rigor education, right? So we've had models where there's been didactic learning. We're moving towards models where we see that, you know, maybe not obviously, but obviously, active engagement helps them bring the practice into what they are actually doing daily. How do you envision that future?
It's hard. So for those who are in science, one thing that the NINDS did is give these, I call them badges, but they're not called badges. Like I did randomize, I did, you know, all these different good practices.
The rigor icons?
The rigor icons, exactly. If we started implementing them and then, you know, you almost, I'm not even going to read that paper because it doesn't have those icons, it might really spread. The problem with that is that what has happened in a lot of journals who have requirements, Ioannidis did a nice study about it where they have the requirements you have to put in raw data, you know, the raw data, and everybody checks that they do, but they don't. So what if people start putting now the icon, but they don't really do it well? So I would love it that there is some check for that so that people don't misuse these, but once they're used properly, I think it would spread a culture where we value it.
Right, because the individuals would see them, become curious about them.
Yes, and then I want them to. Just like now, people have to upload their raw data on, I don't know, Dryad or some, you know, database. Now, if you don't do it, you're, you know. Like smoking in places, you know, it has changed the culture. So I think we can change it. The only risk is we have to do it in a way that we must be sure that the icon really means what it means.
Sure, the checks and balances have to be there, but the concept of kind of that grassroots spreading, right? Even if NINDS is initiating the idea, the adoption of it
Yeah.
is, I think, seems to be incredibly important and possibly more impactful than coming from top down, going bottom up.
Hopefully, yes.
And so thinking about this, and this is actually particularly relevant for me. So do you have advice for anyone looking to start a course or a project on rigor and rigor education like this?
It's a lot of work. I think you have to it has to do with the audience also that you have. Different people will have different requirements, so know your audience. Be ready to do a lot of work, and I would say collaborate with what already exists. Like maybe use some of the modules that are created here. Take
Sure.
advantage of these things so that you don't have to start from scratch. Yeah, that's probably the advice I can give. And I'm here too if you want any advice. I'd be happy to give it.
That's very kind of you, because I think there's a lot to be learned from your experience.
Yeah.
And I think that you've developed something that I dream to develop someday. Those types of things. So it's nearly time to wrap up for this session. But I want to thank you. I want to thank you for being here, participating with the community for rigor. Your insight here and your passion. The passion oozes about it, and I absolutely love that. They're both very important and valuable to us. And I know that your work strengthens our rigor community through your interaction with us, but also obviously is going to impact all the practices that your students have. And I see that through your course structure, you are empowering them. Mm-hmm. You're empowering the learners, which is something that parallels what C4R is trying to do. So we are incredibly grateful that you are here and that you could share that for your time and sharing your experience. And we are so happy for you that you're a rigor champion.
Thank you. Thank you so much. Thanks.